Today, let's talk advanced chemistry, chemistry 2. I'm going to start a section on advanced chemistry. I'm going to do it different than I did the chemistry 1 and the the forensics. I'm not going to have any labs. I'm not going to have any tests. I'm just going to present the material. I'm going to have some practices for you. So that way you can get some understanding of what's going on and be able to help yourself if you need this. And again, if you have any questions or problems, ltswptd at gmail.com, email me. That's Let's Talk Science with Pastor Dan. And I'm glad to give you any assistance that you need. We're going to do a section here of reviewing the first year of chemistry. So I'm going to do 5, 6, maybe 7 lesson sets where I cover the main important concepts that we need to look at. Now, if these help you at all, maybe help somebody else, like, share, subscribe. Again, I'm not really caring about growing much. I just wanted to help people if they need it. And it's for God's glory. Here we have something called sig figs. Now, significant figures is a way of determining the accuracy or exactness of measures. If you're not really ever confident of that, I'm going to tell you, I'm going to go quickly through this. So go back to my Chemistry 1 playlist and days 2 through 4. That's where I talk about sig figs in detail, do practice. I'm just going to go through this quickly, and then we'll do a day of practice on it, so we're good to go. All right, so let's look at the first number. The first number here, I have 0.005470800. How many sig figs do I have? Well, the rules state that any non-zero is significant. So I have the 5, the 4, the 7, the 8. Those 4 are definitely significant. The 0 here is between significant numbers, so it's significant. And these 2 zeros are after a number and after a decimal, so they're showing exactness. They're also significant. So it's 1, 2, 3, 4, 5, 6, 7. I have 7 sig figs. The 2 here, 2 before the 5, are just showing placeholder, how far that 5 is on the decimal. They're not showing any accuracy or certainty about the measure. So 7 sig figs is what we have. Look at the second one. 188, so I've got 3 sig figs, 2 zeros between. Those are all significant. So I have 5 sig figs. These 4 zeros, all they're doing, they're placeholder zeros. Just tell me how far that 8 is from the decimal point. They're not giving me accuracy or exactness at all. Try number 3 on your own. That one's pretty simple. Yeah, we have 3 sig figs because all those zeros before the 5 are just placeholder zeros, just not showing anything about accuracy. Number 4, that's another easy one. People don't like this very much because they look at that and they go, oh, well, that's a big number. Only have 1 sig fig. I would like a lot more digits in there. Decimal places would help too to make more certainty, but that's only one sig figs is as accurate as I can make it. All right, whenever we have an equality or a constant, the number of sig figs is always the same, infinity. So if I have an equality, like 1 foot is 12 inches, or I have a constant, like the speed of light, 3 times 10 to the 8th meters per second, that's definitely significant. All right, let's do the math problems. Now remember, the rules for addition and subtraction is the last filled column. All right, so we take these numbers, and we're going to use a calculator like this and plug these numbers in. Okay, when we do, we get, now, what's my level of significance? Well, the last filled column here is a 10th place because where that 1 is. The rest of these numbers after that 5 and the 10th, I'm not confident. So you look to the right of that. Is that a 5 or greater? It is not. So we just ditch it. So the number is 101.5. That's as accurate as I can be with that number. Okay, for multiplication division, the least number in the problem is the most we have in the answer. Again, taking your calculator, multiply through, I get, now, in the first number, 154.5572, I have 3, 4, 7 sig figs. It's a lot. Great. In 0.0112, I only have 3 sig figs because that 0 is a placeholder. So of 7 and 3. The least number is 3, so the accuracy of my number would be 1.73. Look to the right. Is that 5 or greater? No, it's not. So my answer is 1.73. All right, a little bit more complicated problem here. All right, we're going to take inside that parentheses first, because we do parentheses, and then we're going to divide that through. All right, so if I'm doing 188.75, 18875 plus 13.999999, okay, last filled column is going to be the 1s. So all these 9s are just going to round up. And I'm going to end with 18889. And then if we multiply this, well, the number is 17,555. But because I only have 1 sig fig times 1, I'm only accurate to 1 sig fig. So 20,000 is as certain as I can be as a number. People don't like it. I have all these nice numbers. Doesn't matter. I'm not confident up to 20,000. Now we're going to multiply through. We get 0.94445. And the least number here, then I have 3, 4, 5 sig figs. That's good. 5 sig figs. Only have 1 in 20,000. So the accuracy I get is 0.9. All right, now the other concept I'm going to look in this, I'm doing 2 in this section, is nomenclature. Now, again, if you've not ever done nomenclature before, go back to my chemistry playlist. There's a big set there, 73 through 83. We're going to talk about covalent nomenclature, binary ionic, polyatomic ionic, and I believe acid nomenclature is mentioned in there. If not, it'll be someplace else. All right, let's start with the first one. That's a binary ionic because it's a metal, non-metal bond. We have aluminum. Symbol for aluminum is Al. Chloride, anytime it's an ide, it's the element by itself. That's a Cl, chlorine. Now remember, we go back in the section, we tell you what oxidation numbers. Aluminum is +3, chlorine's -1. We swap them down, we get AlCl3. That's the formula for aluminum chloride. All right, let's look at lead 2 bicarbonate. Now, lead is Pb. Bicarbonate is one of those ones that I have a system called the box rule that I was taught by my teacher, Mrs. Mary Bunny Bunnell. But bicarbonate doesn't fit in that. So what you're going to need to do is HCO3. There's a list of them here. These are ones that you're just going to have to know. Hydroxide, cyanide, permanganate, acetate, bicarbonate, bicarbonate, bisulfate, bisulfite, chromate, dichromate, and ammonium. Their formulas are here. And the oxidation numbers, that's for the whole thing. That's not for the hydrogen alone. So the oxygen and hydrogen together is -1. Cyanide, CnMnO4 is permanganate, charge is -1. C2H3O2, whole thing together, -1. There's my bicarbonate, HCO3, negative. Bicarbonate, CO2, sulfate, sulfite, chromate. Now, these are a little bit different. They have a different structure. Again, the whole thing has that charge. And ammonia is the positive one. Now, because that's -1 and this is 2, this Roman numeral 2 tells us that its oxidation is 2. That's not going to equal 0. We're going to swap them down. We're going to need parentheses around the bicarbonate because all that bicarbonate is identified. So it's Pb, parentheses, HCO3, close parentheses twice. Now for acids, whenever we have acids, we always start with the same element. Start with H, acids are H. The rules for acids, if it's binary, if it's hydrogen with some non-metal and no oxygens, it's hydroic acid. If it's a polyatomic 8 acid, we'll talk about those in a second, then it's an ic acid. And if it's a polyatomic I acid, then it's an us acid. Okay, so this one is hydrofluoric, so that's binary. Fluoric will be fluorine, so put there, oxidation number, hydrogen's +1, fluorine's -1. That's it, we're done. The next two here are our covalent structures again. So there's non-metal to non-metal. Symbol for boron is B, chlorine, Cl. Now we're not doing oxidation numbers here. We're just looking, because remember we're sharing of the bond. How many chlorines do I have? It says tri. Tri is prefix for 3, so BCl3. Let's try going the other way. If I have SCl4, S is sulfur. Now Cl, ACl, again, we said is chlorine, and the ending there won't be ene, but ide. It's always ide, so it's chloride, but there's 4 of them. So what's a prefix for 4? Think of that game with the boxes, the 4 boxes drop, and we call it Tetris. So that's tetrachloride. All right, let's try a binary here. So we have sodium, Na. I would be iodine, but we don't use ine in the end for a binary. We use ide, so it's iodide. Now, remember, we ask ourselves a question whenever we do polyatomics. Do I know the oxidation number of the cation? Do I know the oxidation number of sodium? If I don't, I use the Roman numerals, like I did up here in lead. Do I know sodium? Hopefully remember sodium is always +1. So that's it. We're good. Sodium iodide, we're good to go. K3PO4. Well, K is potassium. PO4, that's one of the polyatomics that I do know. That's the box rule. And again, go back in that section I showed you. I think it's around the 80s there. And I go through the entire explanation of the box rule. Inside the box, outside the box, eights and ites, and the oxidation numbers associated with it. If it's inside the box, O4 is an 8, O3 is an 8, outside the box. Inside the box, O3 is an ite, outside the box, O2 is an ite. All right? So if that's the case, if you look at our periodic chart, phosphorus is inside of that box. So it's an 8, so it's phosphate. Do I know the oxidation of potassium? Potassium is always +1, potassium phosphate, we're done. And then this last one, going back to the acids, that's a carbon 8. 8, we said in that explanation, is an ic acid. So this would be carbonic acid. All right, so there again are my polyatomics you're gonna need. There are the acids, and that is the box rule. All right, that's the review for sig figs and for polyatomics, for nomenclature. We'll practice these tomorrow with 2 sets. That's it. Not too bad. Take care. God bless.